Yeah, so this is what I was saying about dealing with moles and looking for individual particles. So this question says, okay, so what, you dealt with a dozen roses, or three and a half dozen actually. Let's suppose that you want to determine the number of particles of sucrose that there are in 3.5 moles of sucrose. Okay, and the first thing I want to do is really point out what it means to be a particle. So when it says particle, we're talking about representative particles. And representative particles, we've talked about in class already, back in Unit 3. Those are the smallest chunk, the way I like to think about it, the smallest chunk of a substance. Alright, so if the substance is ionic, if it is covalent, meaning if it's a compound, if it's either one of those, or if it's just a regular old element, there's a specific name for the type of particle involved. So the representative particles for elements, I guess, the smallest piece of an element you can have and it still be that element is an atom. Okay. The smallest piece of a covalent compound you can have is one molecule. Okay. And the smallest chunk of an ionic compound that you can have and it still be that ionic compound is a formula unit. And remember, in class, I said that's the only time that you're allowed to say FU in my class. And let's go, you can abbreviate that FU for formula unit and I won't get angry. Okay, I'm not going to laugh myself on camera, that's kind of awkward. So, when I'm asking for the number of particles of sucrose, I must first ask myself, okay, well, what is it? Now, if I were to give you this question in class instead of as an example, I would be nice enough to let you know either the formula for sucrose or tell you myself that it is covalent. So that being covalent, that means I'm going to solve for molecules. All right. And let's kind of first go back and see, well, I treat the formula units for an ionic compound or for a covalent compound or for an element the same when I'm doing this math. Okay. And that's because if I have a mole of a substance, so 1 mole of a substance is going to equal Avogadro's number, so just like 1 dozen, whatever, okay, it would be 12. 1 mole is going to equal Avogadro's number. Representative particles. Okay, so if I'm dealing with 1 mole of an element, that's 6.02 times 10 to the 23rd atoms. If I'm dealing with 1 mole of a covalent compound like water, I'm dealing with this many water molecules. If I'm dealing with 1 mole of salt, which is an ionic compound, I have Avogadro's number of formula units, okay? And it all works the same. It's the same relationship. It's just what you call that representative particle. So in this case, since I'm dealing with sucrose that's covalent, I'm going to say that 1 mole of sucrose equals 6.02 times 10 to the 23rd molecules of sucrose. So molecule would be the smallest particle of sucrose. All right, so I'm given 3.5 moles of it. So I've got 3.5 mole, and we abbreviate mole a lot of the time with just MOL. Yeah, it takes 1 letter off, but it's way shorter. So we got 3.5 mole of sucrose, and I want to get out of moles of sucrose and into molecules of sucrose. Okay. So since I know that 1 mole is Avogadro's number of representative particles, and I want to cancel out my moles, I can put 1 mole of sucrose on the bottom and put Avogadro's number of sucrose on top. And this is where you're going to be really mad if you have big handwriting. Because you're going to start taking up a lot of space on your paper. But it's okay, it's all for science. So you'll see that our moles cancel. We're left with molecules of sucrose, which is our desired unit, so yippee. I'm going to go ahead and kind of put like a circle for my answer. Okay. I'm going to go ahead and write molecules of sucrose. Sucrose. I don't know where the C came from. Okay. So now I'm going to have some number of molecules of sucrose. Again, we don't want naked numbers, so whatever unit you end up with your dimensional analysis, that's going to be the unit that you're going to have here. Okay. see, we got a glare. So here I'm going to take 3.5. And since that's not scientific notation, I'm going to leave it alone. Multiply it by Avogadro's number. So times, and since that's in scientific notation, I want parentheses. Parentheses, 6.02 times 10 to the 23rd. Okay. Hit enter, and you'll see that I get 2.11 times 10 to the 24th. Okay. You'll notice by the exponents that I've got a larger number of molecules of sucrose than I do than there are in 1 mole. Well, I've got 3.5. So really all I did was take Avogadro's number and multiply it by 3.5, the same way that we did with the roses. Okay, so I'll pull that question back up. All right. So this is where dimensional analysis really comes in handy, because a lot of the times going moles to particles, people will think, oh, do I need to multiply? Do I need to divide by Avogadro's number? I don't know what to do. But if you keep track of your units with dimensional analysis, you won't ever mess up when you're converting from moles to particles. Okay, and then later in this PowerPoint, we're going to go from particles to moles, and you'll see that it's just going to be division.